All right. Hi, everybody. And welcome to today's We Ocean Warriors 6 workshop. I would like to thank you for joining us today for this special session on Hitting Rock Bottom, a deep dive into the seabed with Dr. Mazlan. So today we're bringing you geoscientist Dr. Mazlan himself, and he was a former chief geoscientist in Petronas and a Malaysian representative at the United Nations that specializes in the law of the sea. So he's also written a book titled Petroleum Geology and Resources of Malaysia, which is the ultimate handbook for petroleum geologists in this region. So I'm sure we're all excited to know what really happens under the sea.
Oh, that's so cool.
Yeah. He knows a lot about what's going on under there. So do any of you swim or dive, or you've been in the sea? Like, let's see a thumbs up. Well, let's try this thing. It's like, okay, if you've been in the sea, do thumbs up. If you've dived before, you should do a shocked face, because I'll be shocked if you've done that before. Anyone dive? Swim? I think swimming is a good alternative.
I swim.
Yeah, that's
I
great.
was snorkeling.
I've been to a competition before.
Wow, okay. So all of us have had some contact with the sea. So, but the person who really knows what's going on under there is Dr. Mazlan. So it's my pleasure to hand over the session to Dr. Mazlan.
Hello, everyone.
Hello.
Hello.
So thank you for inviting me to this session. I'm really happy to be able to talk to you this morning a little bit about the ocean and the seabed in particular. Coming from a petroleum exploration industry previously, I had the experience of working researching about the seabed and what's underneath the seabed, because in exploration, as you know, we are looking for hydrocarbons, oil and gas and whatnot under the sea, meaning under the seabed, maybe 2 or 3 kilometers beneath the seabed. So what I want to do is in the first part of this short presentation is to share with you the geology, the material under the seabed. Okay, can you see my screen?
Yes.
Yes.
Okay, I make it full screen. So yeah, Hitting Rock Bottom. I chose this title because it's also a cliche, right? When we say hitting rock bottom, means that we are really in a very bad situation, but I don't mean that today, of course. And I mean it literally, in fact, that hitting rock bottom is when we drill for oil, we first drill into the seabed, which is made of relatively soft material. It's just like you're walking on a muddy beach, for example. Your foot got stuck in the mud, so it's soft in the first instance. But as you drill deeper into the seabed, at some point you will hit rock, hard rock. So that's what I meant by hitting rock bottom. So I want to start with this picture of the world with the continents. The white areas you will see are continents, and around the continents are the blue areas, which is referred to as continental margin. So the margin around the continents, right? So it's called continental margin. And It's sometimes referred to in the law of the sea, international law, as the exclusive economic zone. That means the country around the coast are able to undertake economic activities for the benefit of the people. And you will see also that much of the Earth's surface is covered by oceans, the dark blue area, plus all the continental margins. So we as human beings on the Earth, as much as we like to harness the resources on the oceans, we need to take care of the oceans, pollute less, and not to throw rubbish in the ocean and whatnot. And I want to show you this picture of a 3D picture of a continental margin. So you have land, right, up here in the corner, and the margin is basically a flat area which is underwater, what we call the shelf. And beyond the shelf, there's a steep slope that we call the slope, continental slope, in other words. And beyond that is the deep sea. So the deep sea can be as much as 3,000 to 6,000 meters below the sea level. Yes? So there's much that we do not know about the oceans actually. We are only just skimming the surface on the shelf, but there's a lot more about the oceans. As you can appreciate, 70% of the Earth's surface is covered with water, and much of these are deep sea. So deep sea becomes almost the last frontier for humans to explore, to understand the Earth, and as well to harness the resources to benefit the people. So what happens if we draw a profile like this line here across the continent into the ocean, into the deep sea? So we will have something like this, right? A profile like that. So we have the continent, the shelf, and the deep sea, maybe 5,000 meters of water here. Imagine yourself swimming with a scuba gear down the
That's kind
slope.
of scary.
Yes, it's scary, and it's very dark. As you probably seen YouTube videos about deep ocean and so on. I suggest you have a look at those videos. You will see that there are so many unknown or strange creatures swimming around in the deep sea. But I want to talk about the physical aspect of the seabed now. So we usually find near the shoreline, near the continent, you can see stuff like this. We call sand, right? On the beach, for example, you go on the beach, these are sand particles, sand grains accumulated on the beach. But usually when we go more seaward, we will find finer and finer grains or material until we get to the very deepest part of the sea. We have more clay, muddy sediment that are deposited on the deep seabed. So in general, we tend to have coarse grain material near the continent and finer grain at the deep seabed. And this is because of the weathering we have on land, because of the sunshine, the rain as well. Rocks become disintegrated, they fall apart, and they are carried by river into the oceans and deposit into the ocean. So the longer the transport distance from the continent into the ocean, the finer the sediment will be. So there is a general idea we have about the type of sediment on the seabed. Yes? Do I have a question? Okay. Then it's not just the sediment that we are concerned about, it's also what's in the sediment. And lo and behold, there's a lot of interesting stuff in the sediment. For example, we have what we call pollen grains. These are pollen like coming from the flowers
Oh,
on
wait,
land,
how is it in there?
because the rivers carry them into the oceans,
Oh, okay.
right? And along with pollen, we have spores from the fungus, from the from some non-flowering plants, they have spores. And we also have these little tiny shell-like organisms we call foraminifera. So these are very tiny. You can only look at them under the microscope. And even more tinier than those are what we call the nanofossils. Nano means their size is in terms of nanometers. Nanometers, I think, is 1,000 of a millimeter. So you can only look at this under the huge microscope in the laboratory. So these particles are contained within these spores and pollens and microorganisms. We are able to tell, for example, at what depth is the sediment from. So these, we can find different types of these particles at different depths in the ocean. So one way to tell, for example, in the oceans in the past, if we find some particular organisms, we are able to tell the history of that ocean. What was the water depth in the past, and so on. So that's the second aspect of the sediments, the fossilized material. These are all fossils, but very tiny ones. So what happened to the sediment over time? When we deposit layers and layers of sediment, they become pressurized because you have the weight of sediment, right? As you fill up the ocean with sediment, it will become overweight, as it were, and become compacted. And as the sediment become compacted, and we know that the earth is very hot, so the deeper you go into the seabed, the higher the temperature. So over time, it's like cooking a layer cake. So the sediment, the soft sediment, the mushy sediment that you step on the beach, for example, over time, when it gets buried in the deep ocean, it becomes hard and what we call rock. So sediment becomes rock over time because of increased pressure and increased temperature. So that's why I mentioned at the beginning, when we drill for oil at the seabed, we meet with soft sediment, but as we drill deeper and deeper, we come to a point that we will reach rock bottom.
Can I add on something? Yes. Correct me if I'm wrong, but according to your last two slides, because I've read on the internet how rivers flow into the sea, right? And then at the, because fresh water won't really go, but then there are still, the rivers would continue on underwater and create river-looking streams underwater, yes. But it's all just silt and clay.
Yes, that's right. So as you mentioned, if the rivers with fresh water, right? Because it's fresh water, it is more buoyant. So it will stay afloat on top because seawater is salty. So the salty seawater will remain at the bottom, but the river with fresh water will just flow on top.
Oh,
So-
it's like oil and
So
water.
that's, yeah. So that's why the small particles of pollen and spores, they will be carried far away into the oceans, and they will settle down on the seabed after a while. So
And not many
the finer particles will be carried further away. Yes.
and the deep seabed is not often explored, right? Like, because it's really far and people are
Correct.
not really able to research what's going on the deep seabed.
Correct. Yes, because it's very far and also very deep, so it's not very accessible. But at the present time, scientists have studied a lot about the deep seabed. We know a bit more about them, and people are already starting to think about mining the deep seabed for minerals and so on. So that will soon come. Yes.
No, because from your first slide, I noticed from the last photo on clay, like those were the iron deposits from the last
Yes.
exploration in the deep seabed, right?
Yes. So this photo is from the deep seabed. So when I say it's clay, it's not totally clear, right? From the picture you can see. So these small little, well, they're not little, they may be in the shape as big as your palm of your hand. They are called nodules. These are mineralized particles that become big enough. So these are the material that people are thinking to mine, to collect them and bring them to shore to process for valuable minerals.
Because they're used for electronic devices in
Yeah.
today's time.
Yes, they're rich of things like cobalt and iron, manganese, and so on. Correct.
Thank you.
Welcome. So what do we have? Over time, then, we deposit layers and layers of sediments in the oceans, right? So these layers become from sediment, they turn into rock. So that's why when we drill into them, we find soft sediment, and then a little bit harder and harder, and we get to the rocky bottom as much as we can go. So in oil exploration, what we have then is a drilling rig like this one on the picture here. And we drill into layers and layers of rock until we find an oil deposit. And the oil will be within the grains of the sediment that has turned into rock. Right?
Oh.
And as I mentioned earlier, so every layer will have a particular composition of sediment type and fossil type. So that's why we have geologists to study these different layers so that we are able to tell which layer is more likely to contain oil or gas. So the geologist's role is to determine which layers have more potential for finding oil and gas, for example. Okay, so that's why we study all these little bugs in the sediment, as well as studying the sediment itself.
Someone in the chat mentioned, but wouldn't it, Aisha Lin says, but wouldn't it be hard for it to thrive since animals has become smaller due to oxygen?
And well, these particles, they are already dead, right?
Wait, sorry, we were talking about
they're not
megalodon.
living more. They're not living anymore, so they become fossils within the sediment. Once like for example, the foraminifera, they were thriving on the seabed or swimming in the ocean. But once they die, they become part of the sediment. And they get preserved with the sediment grains. Okay.
Thank you.
So, as I mentioned, geologists study all this in the rock, and in order to study them, we learn from the, like for example, we need, if we want to understand the origin of pollen and spores, we study present day plants. So we can relate, oh, this type of pollen grain come from a certain type of plant. And this certain type of plant live in a certain area or certain climate. So from there, we can tell whether this layer of sediment was deposited in a certain type of climate in ancient times. So we can sort of put the pieces of puzzles together to study about the history of the ocean and the history of the sediment in the oceans. So this is, you probably heard of this phrase before, the present is the key to the past, right? So this is one of the most important principle geologists apply, because what we learn of the earth at the present day help us to understand the rocks that were deposited in the ancient times, millions of years ago. Sorry?
Have
But
you
on
ever
top,
been, oh,
do
sorry.
you have a question?
Yeah.
Yeah,
sorry.
go ahead.
Have you ever been in a submarine before?
No,
Oh,
unfortunately,
okay.
no. Not in my work anyway.
Oh,
yes.
but you have been on a big ship to explore the dangerous grounds, right?
Yes. Oh, how did you know that? I have some pictures of that later on. Okay, so so we learn the present day Earth to understand the past history of the Earth. But in addition to that, we can also understand the present by looking at the past history of the Earth. Where do we look for the past history of the Earth? We look at rocks. So rocks, we can study them on land without going to the sea or going to submarines or go on a ship, because rocks, as I mentioned just now, rocks originated from soft sediment. They become buried and then they become rock. And over time on the earth, because of movements on the earth and so on, these rocks will be exposed on land. So a big part of the geologist's work is to study rocks on land. So for example, in this slide, these are what we call outcrops. That means rock that crop out on the surface of the earth. So we study these rocks. We study these rocks because these rocks were deposited millions of years ago in the ocean, in the sea. So by studying the rocks in our crop, we are also able to understand the processes that led to their deposition in the sea. For example, you maybe you have seen many of these features. If you walk on the beach, you can see ripples, right?
Yeah.
Formed by the waves, right? And sometimes you are into scuba diving. Sometimes you can see ripples on the seabed in the shallow sea. But in rocks, we can find these features as well because they have been preserved as rock, from sediment to rock. So if we, for example, if you imagine this beach for some reason they were inundated with the sea by the sea, and then sediment gets deposited on them, and over time they will get buried and deeper, they will become rock, and we get preserved ripples in rock like this. But this rock in this particular picture is from a rock in Bintulu, which is 15 million years old. 15 million years old. They're very old. And this is a cross section of that similar rock, also from Bintulu. You can see the ripples preserved as rock.
How did the ripples happen?
Ripples happen because we have waves flowing back and forth on for example, on the beach here. This is at low tide, so you are able to see them. But at high tide, the water level is somewhere up here. So, like for example here, you have the waves of the sea acting on the seabed back and forth. So they form these ripples of sand on the seabed.
So ripples on the beach or sea floor form just like sand in the desert. They move according to the wave, right?
Yeah, sand in the desert is a similar feature, but instead of water, is in
They
the
move
air.
according to the
So
wind.
the air flow back and forth that's causing the formation of the sand dunes in the desert, right? And besides ripples, we can also find burrows made by worms that once lived in the seabed.
Whoa.
So you can see this
live in
feature
the
here. They are like tunnels, network of tunnels that host the animals. We don't know what the animal look like. I presume it's something like a worm or maybe a shrimp or something. So this is on the seabed, surface of the seabed, and this is a cross section, and you can see the burrows in it. One here, one here. So these burrows also give us some understanding of what happened in the seabed in the past. And in order to do that, also we study the burrows on the present day modern seabed, modern beach, for example. If you walk on the beach, do you see the burrows of crabs, little crabs, and snails? Yeah. So this is the same thing, but these are from ancient times. And we also find little fossils in the rocks. These are from Bintulu rocks. And you can see like cockles preserved. You can see the furrows there, bits of it. We never get really good specimens, but you can infer from their shape and the ornamentation. And we can see clams or kapah, we call it in Malay, examples of those. So these are examples of some of the living organisms at the time when the seabed was being deposited. Again, from examples from Bintulu outcrop.
Doctor, I have a question.
Yes.
This shows this you're using actually Malaysian coins. So this actually is outcrop in Malaysia.
Yes, these are from Bintulu.
Oh, okay.
Bintulu, Kota Kinabalu, we have a lot of outcrops of sediment, and these outcrops are actually we study them because the same rock that contain the hydrocarbon that we explore in offshore Sabah and Sarawak have similar features like these outcrops. So that's why we we study them so that we understand better how to explore and exploit the oil in offshore.
Thank you.
And you notice that I always have this, either my finger or a pencil or a coin, right? This is for scale, so that we know roughly what the scale is, the size of the fossil. And also from Bintulu, we find rocks that are very dark in color. And these are mudstones, what we call mudstones or shale, and they are made of clay, mainly clay and silt that has been turned into rock. And if they are dark in color, it tells us that they contain a lot of organic material. Organic material meaning carbon-rich material that is derived from dead plants. So sometimes you can find plant fossils like leaves preserved in the rock. These are not from Bintulu. This example here is from somewhere else, but just to show you that because we have dark material here, sometimes we find pieces of fragments of plants that are preserved in the rocks. Now, why is it important? Because this organic material is the source of the oil and gas that will be exploited from the rocks. These are what we are looking for in terms of petroleum exploration. The dark organic material in rocks that will turn into oil and gas. As you know, maybe from your classes or from the YouTube videos, the petroleum and natural gas are the product of the dead organisms that are buried in the sediment in the ocean floor, and over time, because of temperature and pressure, they will be turned into hydrocarbons or oil and gas. So that's why we study them in our crop to be able to help us to find oil and gas. So that's why we, as a geologist in petroleum exploration, for the benefit of mankind, for people, for example, in Malaysia, for the benefit of Malaysians, we explore for oil and gas to harness the energy and generate revenue for our livelihood, right? But as much as we like to exploit the oceans for its natural resources, we have to take care of our oceans. And responsible exploration companies will have to abide by the environmental rules, the international law, and so on, so that we minimize the impact of our activities on the environment. So maybe I stop here for a while for any questions on this part of the presentation.
Can I?
Questions?
How do you find out how old like a rock is? Is it like the texture? Do you take something from it? Do you look at through a microscope?
And there are several ways. The main method is from the fossils that I showed you just now. Certain fossils live in a certain time period on Earth. For example, certain plants live in certain times of the Earth. So we know from years and years of research by geologists in many generations, we have compiled and understood that certain types of species or plants, for example, if you find certain type of pollen, we know that it is of a certain age in the Earth history. If we find certain type of foraminifera, we know it is a certain type of. So it's like a fingerprint of the sediment. So that's one way to do it. The other way is we look at the isotopes within the mineral themselves. So these are more complicated. We use equipment in the laboratory to determine the age of the sediment. Yes.
Oh, someone here in the chat is asking, is there a chance that there is water under the seabed?
Yes, 100% chance, because the sediment is actually made up of grains, as I showed you, made up of particles, whether it's sand, silt, or clay. But in between the grains, the particles, is water.
Oh,
It's not empty space. It's
fresh
what
water
is between the grains is water. Is the seawater,
or seawater.
right? So the sediment on the seabed that is soft is actually because there's seawater in the sediment. But as you drill deeper and deeper, the water has escaped because the sediment gets compacted. So you get less and less water as we go into the deeper part of the seabed.
So there are water reserves somewhere under there.
Yeah, water is always present within the pore spaces of the sediment. Even in rock, when the sediment becomes rock, there's still water trapped within the pore spaces of the sedimentary rock.
Wow.
Is
And
it
then-
possible that it
Yes?
dries? The water between the rocks dries? Is it possible?
It is possible because over time, the water will, because of the buoyancy, the water will try always to escape to the surface. And also because when the rock is buried deeper and deeper into the earth, you have this extra heat coming off, and the water will just dissipate through the rock spaces, and there's no space left for the water to stay. So the rock becomes very tight. There's not space even for water to be retained. So 100% rock as you go deeper and deeper. So that's a different type of rock. It's not sediment anymore.
Also, Irdina is asking, if you find a fossil or any sort of historical artifact, is it mandatory and or obligatory to hand it over? And if we do, then to who?
No, generally no. So, like these fossils, they are very minute, and we study them for the purpose of understanding the origin of the sediment, the age of the sediment, but we keep them as archive in the laboratory. And different countries have different regulations. So in Malaysia, for example, all the samples and materials are under the custodianship of Petronas. So Petronas will keep them for future research, maybe. Yes.
Excuse me, sir.
Yes.
Is there a chance that in those water reserves, say, there could be new microscopic lives living in the water reserves under the seabed?
Microscopic organisms, yes, up to a certain point. When the heat gets too much, they will not be able to live, right? Maybe under 1,000 meters or so. There will not be any more living organisms.
Well, but if they could manage to adapt to the heat,
Yeah, some of them, in fact, some of the microorganisms are used in some of the oil recovery techniques in oil exploitation. Yes,
so to
some
say
of them
there
do
is
survive.
life underneath the seabed.
Oh yes, different types of microbes, bacteria, and so on.
Okay, sir.
Okay.
Thank you, sir.
Mhm. What's that?
Oh, cerdak ni kaca dia. Cerdak ni kaca dia.
Shall I continue? Shall I continue?
Yeah.
Okay, so for the next segment of the presentation, I want to talk a bit about the geology as a career. So, as we all know, geology is the study of structure of the earth, and what I mentioned about petroleum exploration, sediment, and so on is only one part of the one application of geology to human life, right? Exploration of oil and gas. But there are other aspects of geology that are used in other businesses, other industries. For example, coal, mining for minerals, and so on. So for students who want to be geologists, sorry? There seem to be some cross line. So geology is a science. So students with a science background are able to pursue geology as a career. You have to have a good grounding in mathematics, physics, chemistry, maybe not so much biology, and also computing would be an advantage if you are into computer coding, software, and so on. Is an advantage. And writing, as I mentioned earlier on, writing is a very important part of a scientist, not just geoscientists or geologists, but other scientists as well, because writing is a way for scientists to share their knowledge with other people. So part of our job is to write about our research, about our findings, so that other scientists are able to learn from us and we learn from them as well. So writing is a very big part of the job. And I always tell people that every piece of rock has a story to tell. As you appreciate, that sediment that comes from the land, transported to the ocean, and then settle on the ocean floor, on the deep sea floor, and then get buried to become a host rock for reservoir. So it has a trail of history, right from the origin, from the weathered rock to the host for the petroleum deposit. So every piece of rock has a story to tell. So I always approach my writing as a scientist as also as like a storytelling. Geology is also an observational science. That means we observe things, we observe the natural world, we observe things from the outcrop, or if you're marine geologist, we observe in the seabed. And it involves a lot of field work, whether it's on a ship, whether it's on an outcrop by the beach, or on the mountain. So it involves a lot of outdoor work for those who like to be outdoors, a very active lifestyle. So this is maybe a good career to pursue, but not always, because many geologists or geoscientists spend a lot of time in the office working on the computers and so on. And quantitative aspects are increasingly important. So besides the sciences, the traditional sciences, we need to analyze a huge amount of data. We need to model the data and so on. So as I mentioned, computing is a big part of the job as well.
May I ask?
Yes.
When you get fossils, where do you keep them? Do you keep them in like a little locker?
Yeah, those tiny fossils, we keep them in very special tray, with small tray, and there's a covering on it so that they don't get spilled. And then we keep them in specialized boxes, in
Oh.
special cupboards. Yeah.
Sorry if I'm asking too many questions, but have you ever found a geode?
Sorry?
Have you ever found a geode?
No, not in my work anyway. So I think those geodes are usually for they can find in mining areas, mining geologists, mineral exploration will find geodes.
What's a geode?
Sorry?
What's a geode?
Geode, if you go to a souvenir shop, sometimes you find this they look like how to say, rocks with crystals inside of it, right?
Yes.
With empty space, but the crystals, you can see the crystal surface.
Oh, that.
Sometimes in jewelry shop they sell this. I think
an extruded, like an obnoxious, highly, a very high price.
But they're very pretty.
For well, that's the commercial side of it, right? And because in some cultures they believe it has mystical powers and so on. They use for ornaments, for decoration, and they can be very big. In some cases, like bigger than the human body.
Wow.
Yeah.
Wait, what?
I'm sorry to interrupt, but I'm in the industry and I found a few geodes during my working.
I can't hear that last question.
I'm sorry, connection here is pretty poor. I just want to say that I'm in the industry, and one time while I was working in coal mine, just letting you know.
Oh, you
Wait, you
working in a gold mine?
Yeah, a junior to my friend, so I want to join to listen.
Okay.
Oh gosh, it's a bit glaggy.
Yeah,
Yeah, the connection here, the connection is really slow. So.
Oh, okay. Maybe you can type in the chat box. Yeah.
May I add something? Can I add something?
Yeah, sure.
If they are looking for geode, they can find somewhere up north in Gunung Kriang. It's my place. They have geode there.
Oh, yeah.
Very beautiful. Okay.
That's
Gunung
good.
Kriang is the place.
All right. Thank you for that.
Thank you.
So, so as I mentioned, these are the fundamental sciences that are applied in geology, and exploration in particular, chemistry, of course, in oil, right? You need to know chemistry, a bit of biology. You know, you need to relate to the living plants from which this pollen and spores come, and we need to know about the living organisms to understand the dead organisms. And of course, maths and physics, because the exploration involves drilling, all the machinery. So a lot of engineering goes into this, right? So these are the fundamental sciences that goes into exploration geology discipline. And on top of that, we need to be able to analyze all the different types of data by computer. So I want to talk about a little bit about my career. So I started in working with Petronas. I was a Petronas scholar, lucky enough to be a Petronas scholar to study geology. And then I worked for Petronas from 1984 to 2013 in the research division in the laboratories. So, for example, this was in the 1980s. I was the one at the microscope there, looking into the rocks. These are samples taken from the seabed, deep beneath the seabed, from offshore Terengganu. So I was looking at all the rock samples from there. This is some of my colleagues in the laboratory. And from 2013 to 2017, I worked in the exploration side of the business to look into the bigger, wider scale project on exploration, both international and domestic. So all in all, I spent 33 years in Petronas. And one memorable time is to spend about 2 weeks on the research ship in offshore Sabah. And here we took a sample. This is 10 meters core barrel that we retrieved from the seabed, and to study the sediment from the core. And while in Petronas, I also do a lot of teaching. As you see, this is in the field at the outcrop. This is somewhere in Miri, and this is in Kota Kinabalu. So a lot of outcrops that we have in Sabah and Sarawak that we study to understand the reservoir rocks in offshore. Compare, this was in 2019, 3 years ago. This was when I started in 1985. Still looking at same thing, looking at rocks. This is a sample of rock from the seabed, but this is deep beneath the seabed, maybe about 2 kilometers below. And my career also takes me to lots of different places to look at rocks. So these are some of the nice examples of rock outcrops that I was able to visit and study. The canyon lands in US, South Africa, Sabah, of course, you can see these beautiful outcrops. New Zealand, for example. So geoscience career takes you to a lot of places, and this is just my compilation of where I've been on study, on business while working with Petronas, and many of them has
I have a question.
Outcrops. Yes.
What is the yellow one for?
Yellow?
Yeah, there's a yellow circle. I don't know what it is.
Oh, that yellow one is my home actually.
Oh, sorry.
Malaysia.
On the map.
You are very observant.
It's so
I
tiny.
I even forgot about the yellow, but that's my home. Huh? What's that?
I have a question, but it's a bit of a weird one and somewhat stupid one. Is there any chance that you might encase fossils in resin or epoxy? Like, are there any instances where you encase fossils in epoxy or resin?
I have not found one myself, but other people have. And in fact, there's a lot of studies on insects in amber from Sarawak or Brunei in our region. In fact.
No, wait, that's not what I asked. I mean, like, if you find a fossil, is there
Yes.
any instance where you encase it in resin or epoxy to quote unquote preserve it for eternity?
No. My collection, I never put them in epoxy, but you can do it if you have the resources, if you have a lab to do it, because you can't do it at home. You need to buy the material and so on.
I see.
Yeah, but I have my own collection of fossils that I pick up during my outcrop studies. I just keep them in a box in the put on the shelf.
I have a question.
Yeah.
So let's say if you all find a fossil, are you obliged to give it to a museum or something, or is it like you can keep it for further studies?
As far as I know, there's no regulation on that. Not that I know of in Malaysia anyway. But the convention is if you as a scientist find something new, then you want to write a paper about it to share to the world, and you might want to preserve it, maybe put in a museum, or because people will be able to look at it, what you've written about it, and look at the specimen for themselves. So maybe you archive it in a museum, maybe museum geology, for example, right? So, but I'm not aware of such a regulation. Often when I travel to these places, when I pick up some mineral sample or rock sample or even fossil, I never got stopped by customs or anything like that. In fact, I remember there's one time when I went to Spain for field work, and I was told, maybe that was the regulation there. I was told to throw away all my samples because we are not allowed to take out the samples from the country. I think it was Spain or France. So different countries have a different regulation. Yeah.
Excuse me.
Yeah.
What is the most exotic creature you've ever seen?
Exotic creature?
Like in the form of a fossil, I guess.
Yes.
Fossil. Well, there are burrows. A lot of burrows. I don't see the creatures themselves, but what remains of it, which I could not identify even to this day. So there are many enigmatic things that we could not identify. Creatures, no. I'm afraid not.
Thank you.
You're welcome. So, so then another part, as I mentioned, writing is a big part of the job. So one of the achievement I'm very proud of is to have written a book for Petronas, which was published in 2000 about the petroleum geology and resources of Malaysia. So this is a multi-authored effort, but I wrote about half of the chapters in there, and it remains still the reference book for petroleum geology of Malaysia. At the current, at this time, right now, as we speak, Petronas is coming up with the second edition of the book. So it has been 20 years or so. And so the last part of the presentation I have today is to talk about what I would refer to as my second career, being in the United Nations Commission on the Limits of the Continental Shelf. I retired from Petronas in 2017, but since 2012, when I was still working with Petronas, I was elected to this commission at the United Nations as a nominee by Malaysia to work on the extended continental shelf under international law of the sea, that any coastal state are able to extend their continental shelf for the purpose of exploring the natural resources on the seabed. So it's important for coastal states to delineate the outer limits of the continental shelf, so that we know that, okay, this is rightly belong to a certain state, and the rest belong to the human or mankind. That means belong to no one, but for the preservation for all mankind. So that is an important aspect of the United Nations Convention on the Law of the Sea. And I was elected for 2 terms now. First term from 2012 to 2017, and then I'm in the second term, almost at the end, will expire next year. And it will remain whether Malaysia would want to again retain the seat by nominating someone or myself to the seat. So this position is by nomination and election every 5 years. Okay. This was the time I lobbied, because the nominating country will have to lobby for the candidate to be elected. So there's a lot of lobbying, campaigning, as it were, for the position. So I was in this photo, I was at a reception to introduce my nomination as a candidate at the permanent mission of Malaysia to the United Nations in New York. So it's like I have to make the pitch to sell Malaysia as a candidate. And these are some pictures from my work. These are my colleagues here. So there are 21 members in this committee or commission, and we work in groups of 7. So we have 7 members working on a particular case, another 7 working on a particular case. And then
does it have to be 7 though?
Sorry?
Does it have to be 7 though?
Because we have 21 members, and then it's in our rules to divide ourselves to 7 groups of 7.
So that's
yeah.
I see.
And then when we work independently in groups of 7, and then we come together, all of us, 21 members, in one big room, in a conference room, in the United Nations headquarters, and discuss our findings and so on, and debate about the issues and so on. So that's me at the end of the table. And the chairman sits in front here. But the downside of it, it's been almost 10 years working on this commission, is that I rarely spend Hari Raya at home, always abroad. So this is a Hari Raya in 2019, I think. Did I write 2019 there?
Yeah, you did.
Yes.
2019.
So
You and
this is
history in New York.
Yeah, that's pretty cool.
with complete baju Melayu with my friend here in front of the United Nations Security Council building. So our conference room is inside one of these in the complex, United Nations complex here. So in New York, you can wear anything, people won't notice. And especially in this part of New York City, because there are many diplomats, so you can find maybe African diplomats wearing African garb, walking. So it's not really a big deal. So we can walk around in baju Melayu, nobody cares.
Because nobody will pay attention.
You know, and a lot
Nobody
of
minds. Like nobody
Yeah.
minds in general.
And there are a lot of tourists as well in front here to get into to visit the security council.
One question.
Yeah.
Are you currently like researching anything?
Yes, on my own as a hobby, although I'm retired, but as a hobby.
On your own?
Yes.
Yeah.
And with some colleagues who are still active, I keep in touch with some colleagues in the petroleum industry, and we collaborate on writing papers as well. So I'm still an active writer.
Why did you retire?
Retired from Petronas 2017.
You can ask him questions.
But as a scientist, you never really retire, do you?
That's right. I mean, I'm still reading and writing things, and usually because when you are actively working with a company, you have less time for writing.
Does
Although I
that
tried
mean
very much. Yeah.
does that mean that you published a book?
The book that I mentioned just now, yes, and
also inside it.
but now I'm writing more technical papers
Yeah,
in
hi.
journals.
Oh.
Oh, doctor, can I ask something?
Yes.
Usually when you find rocks when you were in Petronas, how many groups will there be? And like, will you guys be like sorted from like people who find it or people who like preserve it?
Oh, there are various departments. So there's a department that takes care of the samples and store it and archive it, take care of it, so they're not spoiled and so on. But there are a group of researchers that study them. Right?
Wait, did
So
I
I belong
right?
to
The
that.
rocks can spoil?
Sorry?
The rocks can spoil?
Yeah, if they're not taken care properly, they can even be, subject to, for example, if people come to study, they're not allowed to, for example, scribble the pencil on the surface of the rock.
Oh, okay.
That is something that I did not expect at all.
Wait, what do you
Some
need
people
to
do
do
that.
to take care of the rock?
I feel like
Yeah.
you need to be very careful because like it's an artifact after all and it can be quite fragile.
Yes, that's
So
correct.
you have to research it first and put it in the museum, or you just keep it with you?
Keep it for
No,
further research, I would assume.
in Malaysia, Petronas has a big complex to keep all the samples, and they are stored in very specialized boxes. You use like these long boxes, like this one. But these are in the 1980s. They're not properly done. But nowadays they are very nice boxes, and they
Eloquent.
stack it. It's like a warehouse. They stack it properly. They use crane to get them, put them back and so on. It's very high-tech facility.
Was there any instances where like you have to like monitor something and then you get hurt doing it?
No. No.
What do you need to do to take care of the rock?
Keep them clean. They always they are covered, not exposed to atmosphere, and they keep in air condition.
So you have to wash the rock?
No, you cannot wash the rock, because once you make it
I have a
contact with
question.
water, it will spoil the rock.
I have a question. So you said
Yeah.
that the rock has to be handled with utmost care, right?
Mm-hmm.
So let's say before you found the fossil or the rock, how did it manage to survive in, you know, the extreme cold, extreme heat, in the extreme pressure and everything?
The fossil that we find is in these rocks, for example, they become part of the rock. They become rock themselves. So when we want to study the sample, we, with permission, of course, we collect a little bit, maybe a few centimeters. Very small bit, small pieces. Like in
How
the
do
palm
you
of your
know?
hand, small.
How do you know where the fossils are?
We don't know, they're tiny. We cannot see them with our naked eye. So what we do is we sample at usually at regular intervals, say every 30 centimeters. Take a piece of it every 30 centimeters and then process them.
Man, that sounds a bit hard.
I know, it is.
Can I ask, have you ever found a bone when you were trying to find rocks?
No, I've not found a bone. You mean like dinosaur bones?
Yeah.
No. So dinosaurs live in a certain time in the Earth history. So these rocks, these particular rocks that I'm looking at, they are maybe 15 or 20 million years, right? The age of the rock. But dinosaurs, the youngest dinosaur would be 60 million years. So it's impossible to find the remains of dinosaurs in this time.
I have one
So we have to go
question.
to certain places. Sorry?
Have you found anything else besides finding a rock?
Have I found anything else?
Yeah,
I
while
feel like the
searching for
definite
rock.
answer is yes. Like, come on.
I mean, like he's bound to find more things other than rocks.
Yeah,
Have to
like they
find more
could.
things
There's a
But not
than
like
rocks.
trash. But not like trash.
Has a fish ever followed you while you were finding rocks?
That's a really.
Fish?
That's a
No.
very funny question.
No, it's a sea, so I don't know. I expect fish. Maybe the fish are curious, you know.
Excuse me, sir.
Imagine an axolotl just following them
You-
while finding
I don't
something.
think they live in salt water.
Sometimes you find
Minecraft.
fish remains and so on. But
Oh,
not
okay.
me personally,
Excuse me,
but
sir.
other people do. Shark's teeth, crabs,
Sir?
and so on.
Excuse me, sir. May I ask a question?
Yes.
What is the oldest rock you find?
What is the career
Oldest
prospect
rock.
for me in the renewable?
Sorry, shall I answer the first question? What is the oldest rock?
What is the
I have?
oldest rock that you find?
Oldest rock I found, it's not that I found, but the oldest rock I've seen in Malaysia at least is Langkawi. In Langkawi, the oldest rock, in fact, the oldest rock in Malaysia is in Langkawi. It's about 500 million years old. 500 million years.
What is your aim as a geologist?
What is my
Your aim. Your aim. Like what to accomplish?
as a geologist?
Yeah.
To understand the earth. That is my primary aim as a geologist.
So, you have like any goals like you want to find like a geo or want to find this particular geo like that?
Like a
No,
particular fossil or something.
no. I mean, if I were a mineral exploration geologist, that would be one of my many goals.
So
I
is it
mean,
you find it by luck or chance, or you have something to detect?
usually when at this day and age, in most places on Earth, is already studied by generations of geologists before you. So you would know that, for example, if you want to find dinosaur bones, you would not look for it in Kuala Lumpur, for example, or in Kota Kinabalu, because
Sir,
from the geology, it's not possible. So there's certain places that you have to
What
look
do you
for.
do if you find a geo? Do you keep it? Do you sell it? Do you hand it to a geologist or whatever?
Personally, I would just keep it and put on my shelf.
Secara personal lah.
Of course.
Yeah.
I mean, like, yeah,
Doctor,
it's pretty valuable.
it's really. Well, also, doctor, like, did you always grow up wanting to be a geologist, or it kind of just like came from mind?
Very good
That's a
question.
good question.
Ooh, that's
The answer is no. The answer is no.
really?
I became geologist by accident. I think many geologists will have the same story.
Why did
What? You became a geologist by accident? How does that even happen?
Do you accidentally choose like a university?
It's a long story. I think I need more time to. But
sir,
yeah,
what made you had the what made you had the interest to become a geologist?
as I said, it was by accident. Well, to cut a long story short, I wanted to be an architect.
Oh.
But there wasn't.
What changed your mind?
Like he
Changed
said,
my
it was an
mind because
excuse me, sir.
because the opportunity came for me, because Petronas was at that time expanding, so they advertised for geology scholarship.
Excuse me, sir.
Yes.
If you had the chance to correct that mistake, accident, would you do it in this position now? Would you
No.
like? Would you like would you correct the accident? Like, would you rather choose something else than the geologist?
No,
I
I
don't
think
think
he's
so.
found
I
his
have.
passion in it.
I mean, it's difficult to say, but I don't have any regrets.
When you first
I
started
think I
your
enjoyed being a geologist.
when you first started your work, right? How do you feel? Like, were you tired, or you wanted to quit, or you
I
want to
hated
still
it.
kept going?
When my first field trip when I was studying as an undergraduate, this is just first year geology. I went to the field. I'm not the type who plays with sand, and when I was little, right? When you were little, you play with sand and go outdoors, right? I don't like playing with sand and so on. So when my first field trip, it was a rainy day. Yeah, all and dirty and so on. It was a wet day in the outcrops, touching all the rock surfaces. They were all muddy and so on.
Doctor?
Yeah. Sorry?
Can I ask, like, how do you learn in like the university? Do they like show you rocks and like tell you characteristics, or do you have to like? Oh,
exactly.
That is
so in the university, in the geology course, where you go into the lab, they show you all the different types of rocks, all in little tray, in boxes. Right? So, okay, this is granite, the color, the texture. So you have to learn all these things. And then fossils also the same. Fossils, you have a whole load of fossils, different types of fossils. So you have to recognize, oh, this is, I don't know, trilobite, this is crinoid, all the different type fossils. You have to learn the names and what they look like. So when you go to the field, you are able to tell or recognize.
But
Yes,
when you
that's how we
find
learn.
the rock, is it important to look at all of the details, like even the little details? Do you like, is it important?
It is important. That's why I mentioned just now. It is an observational science. You observe and you note down. You write, okay, this rock is what color, what texture, is it coarse grain, fine grain?
I
Is
would
it-
imagine every little discovery leads to the history more of the specimen more and more. I feel like calling it a rock is a bit insensitive.
Yeah, but exactly is observation, very detailed observation, and just not in observation, just not in the field. You have, if required, you need to take the sample home to your laboratory and then look at it under the microscope, process it, look for microfossils and so on. So as I said, every piece of rock has a story to tell. The geologist's job is to tell that story.
Every
From the rock.
single engraving has its own story to it.
Yes,
Oh my
yes,
god.
exactly.
Doctor,
I have a question.
yeah, can I? Oh, sorry.
I was going
Yeah.
first.
It's okay. You can go first. I'll wait.
Okay. What is the career prospect in renewable energy from a geologist's point of view?
Oh, renewable energy from geologist's point of view. I'm not sure that is well, geologists traditionally, whether you work in mining or oil and gas, you're looking for
non-renewable.
So I think there's, because we are in some sort of transition now, I think many geologists are thinking about going into that transition. I don't know, because the training is different. The training we undergo is different. So you have to attain in different skill sets.
Doctor, has it come to the point that you found a rock so valuable they had to like seal it up?
No.
Oh wow.
afraid not.
I feel like that's what I would have expected if I weren't so simple-minded.
Usually, what we study in the outcrop, for example, they're particularly worthless. The value is actually what we understand from it.
Oh, the value is in the history itself, I would assume.
Yes, is the value is what we understand from it, and what we can learn from it, and we share by our writing.
What happens like if you find a rock, like just by any chance, if you find a rock with a hole in the middle, is it considered as a artifact or something?
Yeah,
Or just
definitely.
normal, or just a normal one?
It doesn't really matter. It doesn't really
with-
matter. As long as it's a fossil, it's still something.
Like a rock in the rock with a hole
Donut
in the
rock.
middle.
Oh, the hole like a barrel.
Donut rock.
Like a hole in the middle, like a donut.
I'm not sure whether I found that kind of rock, but anything that's unusual, usually I'll pick it up and take it home and just put it in my box or on the shelf. So anything that's interesting, that looks interesting. I'll
Okay,
just keep
wait.
it.
How many things are on your shelf right now?
How many things?
Yeah.
I don't know. It's uncountable. Yeah, it's in a box in the storeroom and so on.
Is it your secret stash?
Secret stash, yeah.
Secret stash. Sounds interesting.
Yeah, and also photographs. So nowadays
Photographs?
it's easier to take a photograph, right?
Did you
I
say
have
photographs?
thousands and
Now I'm
thousands of
very, very
photographs.
interested. Because I like taking pictures.
Yeah.
Polaroids especially.
So, for example, my background there is an outcrop in Miri.
Wow.
Are you in there?
Sorry,
Are you in the picture or is it a random picture?
I'm not in there. I'm the one taking the picture.
Oh,
Oh,
See.
it looks like they're climbing it.
Yeah, it's there's some people on top of the ledge and some people.
I would imagine this
just
would
looking at
be
them.
extremely fun to be a geologist.
Yeah.
It is. If you are an outdoor person, you
The
like to
outdoor
be in the
person.
sun.
No, I'm not. Okay.
let's say, wait,
No, no, no,
let's say
goodbye.
if you
Yeah,
fail
I
to
can spend my entire life in my room and I wouldn't have to go out at all. I would rather spend my entire life in my room.
caveman,
Yashvin, you are
I'm so
me.
I wouldn't do
But
that.
but
I
if we
wouldn't
caveman.
do
live
that.
in
I
like
want to
Sun.
explore more. I wouldn't do
maybe
that.
we can live in a rock place.
Yeah.
Someone in the chat earlier asked if you've had any accidents while doing field work.
Not fortunately, no. I have a close shave. I could say. One time, a very close one. I was climbing up. In this was a undergraduate class in a field work. I was the last to come up a very steep cliff. So I followed the person in front of me, a few meters away. And as he was climbing up, he dislodged a piece of rock,
Oh no!
almost hit me in my head.
Oh my god.
But fortunately, it didn't hit me, but it was close shave.
Oh
So
no!
that
to
story
climb.
The amount of
very.
adrenaline I would have.
If
Do you
I
have
were
to
in your
climb like
position,
mountains?
Spider-Man.
Yeah,
my God.
some geologists climb mountains, but I do not. So
I've been thinking about this question for a while. Like, what are the qualifications to become a geologist?
qualifications.
Yeah,
Qualifications.
qualifications.
Or you have to have a degree in geology. One, right?
Doctor,
Yeah.
have you ever found like a new type of rock and got to name it?
Highly unlikely in my opinion.
Yeah, but
No,
it sounds
you
very
are right, because most rocks have been
Already
named
discovered
in
and
general.
named.
They have, you can call a certain rock by a certain name that has been around for a while because people have already classified them.
But if you were
To
to
be honest,
find a new rock, then it will be like, I know you have to go deeper into the crust of the earth to
yeah,
find
exactly.
that rock, because
You can if you find certain rock that somehow doesn't fit in any of the classification, then you have to document it properly. By documenting means you have to write in detail the composition, where it came from, the origin of it, and then so on. So that's why, as I said, writing is a very important part of the.
If you find a rock, right? If you find a rock, the first thing you would do, you share it with your colleagues or study it first?
I mean, you have to study it with your colleagues. So
Yeah, it can be a
Yeah,
bit
what
of both. If you are used to working alone, you do it alone. But nowadays, most people do it in groups.
Doctor,
Yeah.
yeah, I have a question. I might have missed this earlier, but looking at how the rocks were nicely arranged in a box, yeah, I wonder how or what equipment did you use to cut it? Like, do you guys have to carry it all the way? Is it a big equipment? Is it a small equipment?
Yeah. So the samples here, like this one,
I would only imagine it to be
they're
extremely
actually
heavy duty.
originally they're taking they what we call coring. It's like a cylindrical barrel that they use to retrieve the rock from the drilling rig, right? So this may be 2 kilometers beneath the sea. So So what you have is cylindrical piece of rock, maybe a few meters or so. But these boxes are 1 meter each long. So they need to fit the core sample into 1 meter boxes. So they have to cut it into 1 meter length. Besides that, you can see here, what you see is only half the surface. So what, besides cutting it into 1 meter long pieces, they have to slice it with a saw blade. There's a machinery and so on to cut it with the diamond saw to cut the rock. So this is only half. So the convention is you keep half of it for eternity, as it were, so for preservation. The other you can study. So that means it's like the backup. So if you happen to spoil this or destroy it for some reason, or maybe too much sampling, you need to refer back to the original one. So there's another half. So that's the convention.
Do you dig deep down while finding a rock?
Do I what?
Dig deep down
Uh-huh.
while finding a rock or a fossil.
I'm not sure. Do I what? Deep down?
Like if you want to find a rock, do you like dig very deep down, or is just on the surface
Oh,
where you can see?
These samples are taken by the drilling rigs. They are very deep. But at the outcrop,
Doctor,
we just look at the surface. Yes?
Doctor, someone in the chat says, is it true that Malaysia is sinking? So your perspective as a geologist.
Is it true? What? Sorry?
Is it true that Malaysia is sinking due to the high sea levels?
Malaysia is not sinking. I don't know. I haven't heard that before.
Is it
I
sinking?
didn't even expect that.
Huh?
That's weird, actually. Yeah.
Sea level is yes, sea level is rising, but I don't think Malaysia is sinking.
Maybe we'll take one last question, or Dr. Okay to go on?
I'm okay.
Yeah. Anyone?
Oh yeah, I have a question. This was one of the earlier slides, the starting slides, which I forgot to ask earlier. So there was one slide in which Doctor said that rocks can disintegrate into smaller particles, and in another slide he said smaller particles form together to form a rock. So is that some sort of like a natural cycle?
Yes, and that's we call that rock cycle. So from rock, it gets into the surface as outcrop. The outcrop is exposed to sun and rain, and the rock will disintegrate over time into small particles, carried by the river into the oceans, and in the ocean they will settle to the sea floor on the seabed, and the seabed will get buried and so on, and over time it will become rock again. That rock will be compressed and uplifted and becomes outcrop again. So this is what we call as a rock cycle.
So would it become bigger in that process?
No, it
It
doesn't
depends in
become
which
bigger.
process.
What we have is actually a preservation of material, is conservation of material. It's just recycling all over again. It's a bit like the water cycle, right? Water evaporates and become rain and flow back into the ocean, and then evaporates, become rain, flow back to the ocean. The volume is the same.
So in general, it's the circle of life, but for rocks.
Yeah. You can think of it that way.
That's funny.
Yeah.
I was
Yeah.
going to ask, if you were to find any sort of volcanic rock, like multiple of them, do you study them all, or do you classify all of them as the same?
Well, from in the field, you'll be able to tell, okay, this rock looks different from that. So you, as much as possible, you note it down in your notebook all the different characteristics of different rocks. And then you say, okay, it's not enough just to do it in the field. You have to take sample home to study them at home. By home, I mean, if you are a retired person like myself, I don't have any access to a laboratory to study in more detail, right? Unless if you are an active geologist with an employer with a laboratory facilities, you are able to do that. So that's why I keep in touch with the sectors. Yes, we try to document as much as possible. Yeah.
All right. I think
Bork.
that's been a lot of questions from the audience, and everyone's like really interested with with rocks. So I think
Where can we sign up?
sign up to be a geologist?
Yeah,
that would be fun.
Wow, okay, then you have to email Dr. Mazlan about that. he teaches too, so you might get to learn a few things from him.
I guess I'll just stay on the path to become a lawyer. Thank you.
Oh.
Okay.
I guess I have like 5. I think I have 2.
Yeah.
So,
that's good. You are determined from the beginning.
Dr. Mazlan, are you okay to wrap up today's session?
Yeah. Thank you very much for those questions.
Thank you, Dr. Mazlan.
Thank you.
Thank you so much.
So
Thank you all. Thank you very much.
Arigato to you for enlightening us.
Thank you for
listening.
teaching us.
Arigato gozaimasu.
You're most welcome. Arigato.
Thank you, doctor.
Thank you.
Thank you.
Please
Good
take
luck with the competition.
Interesting information.
Yes, very, very interesting indeed.
Dr. Mazlan.
Dr. Mazlan, so on behalf of everyone here today, thank you for taking the time to speak to us and share your expertise. So clearly your insight to the seabed and geology rocks.
Rocks.
Nice.
Rock on.
Yeah, and seems like we might have sparked some interest in this field because now we know it's everywhere. And there are lots of opportunities to work with the ocean as an explorer, as a scientist, computer programmer, and your writing skills, you know, that's something that would serve you for life. And on that note, our deadline is on the 31st of August, 2021 at noon. So you might want to get your drafts in the final polishing stages. So if you'd like to share this session, it'll be available to stream on our TOEFL WOW writing workshop channel on YouTube. And there's a session tomorrow with teacher Aini on bringing life to fictional writing. So hope to see you
I have
there.
a question
Once
about
again,
short writing.
on behalf of everyone, thank you so much, Dr. Mazlan. And
I have a question about the short writing.
enjoy your day, everyone.
Bye.
Oh,
Excuse me.
Yes.
I have a question about the competition, the short story competition. About on anything, right? It can be done on any topic, right?
Can you repeat the question?
The short story writing can be done on any topic, right? As long as it's a story, right?
It must be related to marine conservation.
Oh, okay.
Oh. Can I write about rocks?
You write about rocks and how it can save animals.
Rocks really rock.
Yes.
Rocks really rock.
Right.
So we need to write the story as long as it related to the topic that you gave us, right?
Yes.
Thank you.
Thank you.